Let's take a look at this example. We have emitter bias configuration. We're supposed to find IB. Okay, in order to find IB, let me just give you some extra explanation. We have formula which says IB is equal absolute value of VEE minus VBE over RB plus beta plus 1 times RE. Okay, so we have VEE over here. Okay, so this is my voltage source which is connected to the ground by the positive terminal, and the current is going to flow. Keep in mind we're using the conventional current flow. It's going to flow through the ground. From the ground will go through the resistor and will go to the transistor, to the base. Okay, and from the base will go to the emitter. That's why we have VEE minus VBE over RB plus the transistor times the resistor RE. Okay, so we have VEE equals absolute value of -8 is 8 volts minus 0.7 volts over, open parenthesis, RB 22 kilo ohms plus beta plus 1, 100 plus 1 gives me 101 times RE, which is equal 6.8 kilo ohms. Okay, close parenthesis. This is equal. So let me use the calculator. I have 8 minus 0.7 divided by, open parenthesis, 22 exponent 3 plus 101 times 6.8 exponent 3. Close parenthesis. This is equal 10.3 microamps. 10.3 microamps. Okay, so this is my current IB. Next, I'm supposed to find the current IC. The formula for IC says IC is equal IB times beta, where IB is equal 10.3 microamps times beta, which is equal 100. Okay, so this is equal 1.03 milliamps. Okay, so this is my current IC. Next, I'm going to find current IE. IE is equal IC plus IB. Okay, because these two currents, I mean IC and IB, will meet together and they are going to leave the transistor by the emitter. Okay, this is my IE. So that's why I say IE is equal IC plus IB, and my IC is equal 1.03 milliamps plus IB 10.3 microamps, and this is equal 1.04 milliamps. Okay, so this is my current IE. Next, I'm supposed to find the voltage VB. Voltage VB is the voltage between base and ground. We found already the current which goes through the resistor RB. And keep in mind, we're using conventional current flow, so we assume that current flows from the positive terminal to the negative. So my current is going to flow this way, clockwise, okay, in this loop. So I'm going to enter this resistor from the bottom, and I'm going to leave from the top. So if you are going to measure voltage between base and the ground, you are going to measure negative voltage. Okay, so VB is going to be equal simply IB times RB, where IB is equal 10.3 microamps times RB, which is equal 22 kiloohms. Okay, so this is equal, keep in mind this is going to be negative because we have negative sign over here. So this is equal 10.3 exponent 6 negative times 22 exponent 3. This is equal 226.6 millivolts. Okay, negative. You are going to measure negative voltage. So next we have to find the voltage at the emitter, the VE. Okay, so I have a VE is equal VB minus VBE. Okay, so voltage at the base minus voltage between base and emitter will give me voltage at the emitter. So I have negative 226.6 millivolts minus 0.7 volts is equal negative 926.6 millivolts. Okay, so this is my voltage VE. Next I'm supposed to find voltage VC. VC is equal VCC minus IC times RC. Please notice that the current times resistance is equal voltage. So if I know the current which goes through resistor RC and I know the resistance, I can multiply them together and I'm going to obtain the voltage VRC. So VCC minus voltage across resistor RC will give me the voltage at the collector. Voltage at the collector is the voltage between collector and ground. So I have VCC equals 12 volts minus IC, and we found IC is equal 1.03 milliamps times RC, which is equal 3.3 kiloohms. Okay, so this is equal 12 minus 1.03 exponent 3 negative times 3.3 exponent 3. This is equal 8.6 volts. So this is voltage at the collector. And next we're supposed to find VCE. VCE is the voltage between the collector and emitter. So we're supposed to simply subtract VC minus VE. We found that VC is equal 8.6 volts minus VE, which is equal negative 926.6 millivolts. Okay, so this is equal 8.6. Okay, negative times negative will give me positive plus 926.6 exponent 3 negative is equal 9.52 volts. 9.52 volts. Okay, so this is the voltage VCE. Next I'm supposed to find the saturation current. This is the maximum current which will go from collector to emitter, and the formula for it is IC sat is equal VCC minus VEE over RC plus RE. Okay, so I have VCC equals 12 volts minus negative 8 volts over RC, which is equal 3.3 kiloohms plus RE 6.8 kiloohms. Okay, so this is equal. Negative times negative will give me positive, so I have 12 plus 8 is 20, so I have 20 divided by, open parenthesis, 3.3 exponent 3 plus 6.8 exponent 3, close parenthesis. This is equal 1.98 milliamps. So I have 1.98 milliamps. Okay, so this is my maximum current, which will flow from the collector to the emitter. Okay, over here, from collector to emitter by the transistor. So next we're supposed to find VCE off. VCE off. Okay, so this is the voltage between the collector and emitter when transistor is not conducting. So the formula says this is equal VCC minus VEE. Okay, so this is equal 12 volts minus negative 8 volts is equal 20 volts. Now we can say that the problem is solved.